Hey guys, just going to do a recap video of Unit A circles and just some of the topics that we've already covered. So the first thing that we covered in this unit was vocab of circles. So a few of these here, let's start with tangent. Remember that a tangent is a line that intersects a circle at exactly one point. So in this case, the point where we intersect is point B, but that is not the tangent. Tangent is a line. So the line that goes through that point is line DE. And remember, since it's a line, we have to put the arrows over top. There's a couple other ways you could write this line. Technically, line DB would work as well, since that goes through point B and is on the same line. Or you could go with line BE. All of those would work. Next one we want to look at is the radius. Remember, radius is an extension from the center of a circle to one point on the circumference of the circle, so on the outside. So if we look at C, which is our center, we have two different options here. We could go from C to A, and that's a segment, so we just put the line over top. Or we could go from C to B. Then the diameter is just the whole extension, all the way across the circle, goes from one endpoint to another, but it has to go through the center. So in this case, the only option that works is AB. Then we have a chord. There's two options that would work for the chord. Chord goes from one point on the circle to another point on the circle, but it doesn't have to go through the center. So technically, the one that we would probably think of first is AG. That is a line segment, goes from one point to another. Or technically AB is also a chord, even though it's also a diameter. That's just the more specific name. And then our center point is just C, point directly in the middle. Now a secant, if you remember, a secant is a line, and it's just like a chord, but remember a line goes on forever and ever, so there's only one example that works here, and that would be AG. All right. So that's just some of the vocab that we've already covered. A little bit more on that has to do with the types of tangents. We have common tangents where it's a tangent to more than one circle. And there's two different types of common tangents, internal and external. Notice that with the internal tangent, it is tangent to points that are in between the two circles. And then the external tangent is on the top side of both circles. All right, so after we were done with vocab, we moved on to arc measure. Arc measure has to do with the distance around the circle that is covered by an arc. And basically, it's like the angle measure that is covered. And we think of circles being out of 360 degrees. So if we look at this first one here, we want to find the measure of arc PQ. So PQ, we always want to go the shortest distance from P to Q, since there's only two letters. We need to find that measure here. So we find that by figuring out what is the degree measure of this angle right here. And since it's a vertical angle with SUR, we know that it has to be 42 degrees, therefore making the measure of this angle 42, or this arc 42 degrees. Next, let's go to number 2, measure of TQR. So TQR. If there's 3 letters, you have to follow the order of those letters. So this is a much bigger arc measure. And we know what from T to P is 64, P to Q is 42, but we need to figure out what is Q to R. The easiest way to figure out what Q to R is to think, well, do I have any diameters? Because we know that if you can find a diameter, that covers half of the circle, and half of the circle is 180 degrees. So if we look from P to Q to R, that's this distance right here, and that is half of the circle. So Q to R by itself, from here to here, is whatever 180 minus 42 is. So let's go ahead and do that really quick. 180 minus 42. That's going to be 138 degrees. So that's what this is right here. Okay, let me erase some of this extra stuff I have here. So basically, TQR is going to be 138 degrees plus 42 degrees plus 64 degrees. And that's going to total to be 244 degrees. Excuse me. Next, let me just erase some of this here. I'll rewrite those angles that we had. 42, 138. For the measure of S to T, that is going from S to T right here. We always want to go the shortest distance. Unless we're given 3 letters, then we have to follow that pattern. So we know 64, we know 42. We're just missing this angle right here. So one way that we could think of it is, we know that from P to R, that's going to be 180. So we could just take 180, and we can take away those other 2 angles, which is 64 and 42. And when we take those away, 180 minus 64 minus 42, we end up getting 74 degrees. Sometimes it's easiest to just go ahead and figure out what are all the individual angles, and then you can just do the problems afterwards. Okay, one more to go here. Measure of PQS. So P, start here, Q, and then all the way to S. The easiest way to go about this one is to think about, well, the distance from Q to S is a half circle, making it 180, and then the distance from P to Q is 42. And since they're side by side, we can just add them together. So 42 plus 180 gives us a total of 222 degrees. And there we have it. Continuing on with the same concept, we identified these arcs as either major arcs, minor arcs, or semicircles. I'm going to use theta to represent an angle. I'll write that down here. Theta equals angle, shouldn't say angle measure, arc measure. Remember, theta is just, it's a variable just like x, but we use it to represent degrees. So theta is the arc measure. If theta is less than greater than 180, we know it has to be a major arc. If theta is less than 180, it's a minor arc. And if it's exactly 180, then we know it's a semicircle. So this first example here, we're going from A to B. That looks probably like 80 degrees, 90 degrees. And since that is less than 180, it is going to be a minor arc. Next one, now we're going backwards. We're going from A to D to B. And that one's much larger than 180. So that has to be a major arc. And lastly, we're going from P all the way over to Q, which goes perfectly around halfway, which means it is exactly 180, forming a semicircle. Now on to the last slide. So calculating the length of an arc. Remember that calculating length is where we're actually looking for those meters, those feet, inches. We're not looking for a degree measure. We are looking for a distance. So the distance from A to B is our goal. That's this distance right here. And the way that we find that is using the arc length formula. Arc length is equal to the circumference times the fraction. And in this case, I'm just going to use arc capital L equals, remember for circumference we use 2 pi r, and the fraction is going to be, I'm going to use theta again, over 360. Theta is just that angle. So in this case, our radius is going to be, I'll write it over here, r equals 2, and that theta, which is the angle, is 88 degrees. So to find our answer here, we just have 2, and then we have pi another 2 for the radius, and then it is 88 degrees. And the reason we use 360 on the bottom because that's the total number of degrees for any circle. So plug those into your calculator, and you should get, if you round to 2 decimal places, it's about 3.07 meters. All right, so these are all concepts that we covered back when we were together in class. Going forward with this, you will have a worksheet that follows this video and just goes over some similar problems. Please let me know if you have any questions. Otherwise, have